Um, in this video, I'm going to discuss chapter 22, electrostatic, and we're going to focus on the concept of how things are charged, and also introduce the concept about electric induction. So you've seen in a demo, I charged the balloon. How did I charge the balloon? Is by rubbing the balloon with my hair, like this. You see my hair has got stuck a little. You see it? See? This is, I'm simply by rubbing a balloon like this. So before rubbing a balloon, this was electrically neutral. My hair, myself, was electrically neutral. What does electrical neutral mean? It means that you have the same number of electrons and the same number of protons, plus and minus. You have the same number. So overall, the sum of the electric charge is zero. So that's electrically neutral, right? But then when I rub the balloon, it's so easy to rip off the electrons or add the electrons in it. So what's happening is by me rubbing the balloon, the electrons, some of the electrons are shifted from my hair to the balloon. So now after the rubbing action, the balloon is negatively charged. And I am slightly positively charged, but I'm standing, I'm grounded probably, hopefully. I touched a metal object or my feet is on the ground and hopefully I'm grounded so I won't be getting an electrostatic shock, but you see it? So object can be electrically charged by simply just friction. You apply some friction, then you rub off some of the electrons or add electrons into one object together. Just some objects have a tendency to be positive or negative. Some object has a tendency to be, so it works better with the hair. It works less with the other objects too. So the material property do matter, makes a difference. But yes, you can easily charge the object by friction. Then I mentioned that if I touch the object, so this same thing happens with in a cold winter climate, right? The air is pretty dry, and you walk, and sometimes maybe it's just the way I walk. I tend to be having a lot of electrostatics. So because the sole of my shoes and then the ground, or it could be the carpet or something, every time I walk, there's friction. And this friction causes myself to be electrically charged. And if the air is dry, the air is more considered to be what? Insulator or conductor. The dry air is conductor or insulator. Dry air is an insulator, right? So that means that electrons are not, you don't have a flow of electrons. So by friction, I have some extra electrons. I lose electrons. I become a little bit positively charged, right? My hair becomes, each of my hair is positively charged. So they all become repel, right? And then because the air is an insulator, that means the electron cannot pass through. So it stays in me. So I become charged. Then what happens when I touch the doorknob? What kind of electric material is the doorknob? Doorknob is made of what kind of material? That's right. Typically, the doorknob is made of metal, and therefore metals are conductors, electric conductors, okay? Metals are conductors. So then what happens is that I'm charged and I touch the metal. Anyway, I touch the metal, then the electrons flows either from the metal to me or me to metal, and then I get electrocuted, like electric shock. Or when it's about to touch, that's when I get little spark, when I'm just about to touch. So because see again, the key thing is that metal is a conductor, and the conductor can have conductors have free electrons. So that means that electrons are free to move around. Insulator, like a dry air, you don't have electrons can flow around. So I just have a charge, and then the charge stays in me. But if I touch the conductive material, electrons can flow from the charged object to the doorknob. Initially is electrically neutral. But after I touch it, the doorknob becomes charged. So let's see all these concepts. This action that happens in conductors is called induction. So I don't have to actually touch the doorknob. I could just bring the charged object close by to the metal like this. So the charged object close by. I don't even have to touch it. So when I'm not touching, this one has an electrostatic force, right? Because of you have a charged object. And then to have an electrostatic force, you need to have a two charged object. You don't start low, they all have to come in pair with the two different objects. So two charged objects. This is not charged. It's electrically neutral in the beginning. But I bring this balloon that's charged. And electrically neutral object will be induced. So it looks like one end. So if this is negatively charged, the balloon is negatively charged, then one side that's closer to the balloon becomes positively charged, the other side becomes negatively charged. But overall, it's still electrically neutral. And this is called induction. So I'm going to show you all these in a whiteboard and a slide. So let's see, share that screen with you. Here. Okay. Sorry about that. Okay. Here. So this is, we're in chapter 22. Charging. You can charge the object by friction. So all you need is just a friction motion to, friction can rip off, friction can rip off or add electrons to the electrically neutral object. It to the initially. So the example is like rubbing balloon. What happens is that initially we have the same number. I'm holding a balloon, and then this is my hair. right? So we have initially I have a plus, minus, plus, minus, plus, minus. Okay, and then the balloon also has a plus, minus, plus, minus, plus, minus, right? By rubbing it, this minus will go into here. So 1, 2, 3, 4, 5, 6. And then this 1, 2, 3. Okay, I get it. Sorry. With the initial balloons. Green. 1, 2, 3. And then I also have an initial plus balloons. So this blue has moved here. And therefore green plus moves, minus moves. So then after you rub it, I'm holding a balloon. That's negative, something like that. So now this is electrically charged. Balloon, electrically charged by friction. So you have an excess number for the object to be electrically charged. You need to have an excess number of electron or deficiency of electrons, right? And then same thing happen. You can be, combing your hair. Walking. You get charged rather easily. So these are charged by friction. Then what if you touch the object? What if you make a contact with conductive material? Because you know that, well, it happens with the wood and stuff too, just slower process. If it's completely insulated material, like I said, after my hair is being combed and then or rubbed by balloon and then it's electrically charged, so each of my hair is positively charged. So you have a positive and positive, it's going to be repelling, right? So you see my hair, it would stick up with the electrostatic force. But then it keeps sticking up in the dryer because the electrons are not moving. It just stays there. But if I touch the conductive material, then electrons can flow in the conductive material. So when you make a contact with the conductive material, you can induce a charge, or you have a flow of electrons, and you can charge the conductive contact with the contact material and charged object. The charged object initially electrically neutral, neutral, conductive. Now now is charged. So let's see. If you have a charged balloon here, right? Negative, 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 negative. And then I could have a can. Coca Cola or something. Let's say a can, aluminum can. Aluminum. Which is, aluminum is a metal, so it's a conductor. What happens? What happens? Actually, even step one, even before it touches, step one, bring the charged object near the conductive material. So here I have a Coke, right? And this is electrically neutral. But if I bring the balloon close enough, right? This is charged. Let's say negatively charged. All right. Then, yes, the can is electrically neutral, but it doesn't mean that they don't have a protons and electrons. They have the same number of electrons and protons, right? So when the negatively charged comes closer and the can is made of metal, metal has a free electrons. Electron can move around freely. These electrons, that same number of protons though, feel the negatively charged balloon coming closer. So you have both positive and negative in a can. I don't have a can here, but you have a positive and negative. This is not a metal, but this one has both same number of plus and minus in it. But when the minus object comes nearby, right, then the minus inside the can. The minus that's initially, so initially there's a plus, okay, there's a plus, right? And then 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Right? Initially like this, they will feel the negative thing coming and one, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Then this negative inside the can, they repel with the negatively charged balloon. Coulomb force, is that contact force or non-contact force? Right. Electrostatic Coulomb force is non-contact force. So you don't have to be in contact to feel the force. So this negatively charged electrons in a can will be actually, they can move around inside the can. So they repel. 1, 2, 3, 4, 5, 6. And at the same time, the positively charged object can move onto the other side. Or it looks like they moved, left over. So this is still neutral. And then it's not in contact. But you are inducing this is called electrical induction. You're inducing a charge in an electrically neutral object, the conductive object. So this positive and negative, they will be, I can actually change the color. Let's do orange. Orange. They're going to be attractive. They're going to attract each other because this is positive and negative. So then it's easier for the balloon to stick to the can. They will attract. All right. Once it's in contact though, what happens? Step 2. So that's bring the balloon near the conductive material and you induce the charge. Number 2, make a contact. Contact with neutral conductive material. So then, now let's see. I am actually touching, oops. All right. I am going to touch the thing, but looks like I'm running out of my charger. Here. Sorry. I am going to stop the video for now because my pen's charger is running out. Hold on. Pause. Okay, so now I'm back. I charged up a pen and let's get back to the share screen. I see you there. Here. So let's see. Now, instead of not just bringing it closer, I'm going to now touch the can with the charged balloon. So again, this can, by bringing the balloon closer, the can is induced. Can's charge is induced, but it's still electrically neutral. But once we make a contact, when it touches, so this time it's touch. Here. Then blue. It was there's extra electrons. They like to repel, so they like to go and come inside here. Right? Then overall can and a balloon. 1, 2, 3. 1, 2, 3. They're both charged. But you see that balloon is not as much charged because they gave some of the, probably the half of the electrons to the can. And now the can is negatively charged. Now charged. So you can charge the object by friction and contact. So this can has been neither of them initially was charged, and balloon got charged by friction, and then the conductive can got charged by contact with the charged balloon. So this is the way that you can charge the object, charge in contact. And again, let's review the process of induction. Induction. So let's say you have one side, you're going to have a neutral conductive material. It's electrically be neutral and electrically conductive material. So let's say I have a piece of a metal that's not charged. So I have a 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So the number of minus and plus is the same. But if I bring the object, let's say this is a positively charged object. It could be negative, whichever object. Bring it closer. Bring closer. So this one has something like that. Then although the number of electrons do not change, but they feel the positive that's coming close. So the negative inside the material move towards it, gets attracted. And the positive will be repelled. It goes to the outside. So this object kind of looks like there is a positive and there is a negative. But still, overall, right, it's electrically neutral. It's not charged. Not charged, but acts like you have a negative on one side and then a positive on the other side. So you just have a charge that's induced, and that means that charges are separated at two ends. And this is process of induction. Oops. I saw her. All right. So let's see what happens. I bring, let's see, I'm holding a negatively charged object here. And there is two conductors here. Two conductive balls that's initially touched. Initially touched in neutral. If I bring it closer, sorry. If I bring this negatively charged object closer, what happens to these two balls, right? If I bring it closer, no, they're contact. So like this, connected, and then I bring it very close. Minus, 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 minus. Then they have a same number of plus, 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 minus, 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 minus. But then if you bring this negatively, I wanted to change the color, negatively charged object closer, 5, 6, 7, 8. Then minus will be repelled. So 1, 2, 3, 6. 1, 2, 3, 4, 5, 6. And then a positive will be attracted. 2, 3, 4, 5, 6. Then if I separate them, while still have this charged object nearby, I'm still having a negative one closer, but I am going to separate these two balls. Separate them while this is close by. Then still we're going to have a positive on one side and negative 1, 2, 3, 4, 5, 6 on one side. Then I remove this charged object away. This one and this one, now they're going to be individually individually, this is going to be, one of them is going to be positively charged. And this is going to be negatively charged. Sounds good. So this is also, you can use the induction to charge the object. We just separate them. We didn't touch it. Initially was touched and we separate them. While we put the charged object nearby, we don't need to make a contact. They can just, they can be charged by using induction. What happens to the, let's say here I have a ball that's hanging, it's neutral, right? Another example. And then I bring a positively charged object nearby. Then it's going to be negative will come on this side, and then a positive will come on this side. It's the induction. Right? This is a conductive ball, again, conductive. What happens while I have this bar nearby? But I touch the other side with my finger. Touch. What happens? So we can discuss this in a discussion, and you can answer what happens to this. Okay. Let's see. Let me share the slide real quick, and then we can end this video. Here. So here is the charging. You can charge the object by friction and contact. You can stroke the cat's fur, combing your hair, rubbing your shoes on a carpet. All this friction motion, you can charge the object by friction. And then that's because the charging happens, it's because of either you have a deficiency or excess electrons. So electrons is the one that transferring from one object to the another object. And they can transfer by simply touching. You see the clouds up in the sky, and ground is typically our ground is not perfectly electrical neutral. It tends to be positively charged sometimes, especially when you have a clouds on top and things. So they're slightly positively charged. Because of that, when you have a thick cloud like this, and the cloud is made of the water, and it's very conductive. Then because you have a water, right? And then you have so because of that, you have a positively charged ground. So the bottom of the clouds tends to be negative, and the top tends to be positive. So you can induce the charge in the cloud. And you know what happens? If this builds up more and more and more, then you have a lightning. And actually the lightning is called a dielectric breakdown. You have an air that's supposed to be insulator. Air is insulator, and insulator, another name for the insulator is dielectric. And it breaks down. If you have enough charge that's piled up, this insulator cannot hold it, and then electrons actually cuts through the insulator. And that's the dielectric breakdown that you have a lightning. You can kind of see that though, that there's this pointy tall object. When you have a pointy tall object, that's where electrons tends to pile up more, or the positive charge tends to pile up at that pointy and tall object. So that's why that lightning tends to happen to the tall and a pointy object. And I'll tell you more when we discuss electric field. Okay. But that's the charging by induction. This is also the example we just did. You have a conductive balls, and then when you bring the negatively charged object nearby, and this A and B are initially in contact, then the positive will be attractive and negative will be repelled. And while you have the negatively charged bar nearby, you separate the A and B, then you let go of the bar. Then now you're going to see that A is positively charged and B is negatively charged. Okay. So that's about it that I want to talk about, I believe. Okay, so yeah, this is a discussion about the charging by friction and contact, and we also introduced the concept about induction. Can you have an induction in a paper? Do you see induction in a paper? So that's going to be another question I may ask in a discussion. All right. So I'll see you in a discussion.